Okay, so in this PowerPoint or in this video, we're going to just go over really quick the most missed questions in your exam one. I just want you to have an idea of what the questions were and their answers, as well as why they were that way. I wouldn't be surprised if you saw these on another exam or even on the final exam. So just kind of keep that in mind as we're going through these, or something very similar. So we're going to start off with our first question. It says, Martha conducts a research study in which she measures how long participants spend trying to solve an impossible problem-solving task before giving up as a measure of perseverance. In this example, perseverance is an example of blank. And on this particular problem, you had 4 different options. You had operational definition, dependent variable, independent variable, or construct. So this particular problem is a construct. Okay, remember that construct is an, I'm going to say idea, although that's not really one to, that cannot be measured directly. So if you think about perseverance, perseverance is not something you can physically see somebody do. You can't see somebody persevere without having some type of measurement of that perseverance. And the way that she's measuring the perseverance here, how long the participant spends trying to solve this problem, this right here is your operational definition. Okay, so things like happiness and perseverance and sadness and things like that are not directly observable. We have to find some way to measure them, and we do that through this operational definition. And remember, the clearer our operational definition is the better it is for further research, because we want to try to make sure that people understand exactly how we decided to measure something. So like in this case, the measure is how long the participant spent trying to solve the problem, but we're still measuring perseverance. So hopefully that makes sense. So let's look at the next one. So this one I did a lot because a lot of you guys got the first column right with the frequencies, but we had some issues with the last 3 columns. So I wanted to make sure we understood how to do those last 3 columns. And then some of you got this problem, some of you got ones that had the numbers 1 through 7 in it, but it's the same problem, just different numbers. So first off, I want to notice one thing. Notice that my scores here, they go from the bottom up, the smallest numbers at the bottom, the largest numbers at the top. That's going to come into play when we come over here and we do our cumulative frequency and our cumulative percentage. Remember, when you're doing those last 2 topics, you always want to go from the smallest number to the largest number. So we're actually going to go backwards on those. And then the frequency and the percentile we can just do as we go. So first of all, we're going to just count the numbers of each of these. So you notice we have 120. So I'm going to go ahead and cross that 20 out. I'm going to put 1 here. And we've got 2 19s. So that's going to be a frequency of 2. For 18, we have 1 and 2. So we've got 2 18s. For 17, we have 1, 2, 3, and 4. So we have 4 17s. Again, I'm going to cross those out. And 16s, we have 1, 2, 3, and 4 16s as well. So, oops, didn't mean to do that. Let me go back. There we go. And so we can cross all those 16s out. For 15, we have 1, 2, 3, and 4 15s. For 14, we just have 1. And for 13, we have 2. All right, so now to do the percentile, remember this is just the frequency divided by the number of scores. And if you'll notice that there's 10 scores in a row. So if I have 2 rows of them, I have a 20. So my n is equal to 20 here. So when I do this, it's just going to be my frequency divided by 20 for this particular problem. So if we start off with 1, I'm going to go ahead and pull my calculator out here. So I can do 1 divided by 20, and we get 0.05. And we get 2 divided by 20, and we get 0.10. And the same thing here, 2 divided by 20 is 0.10. So now we're going to do 4 divided by 20. So that's going to give us 0.20. And really for the rest of them, we have all the numbers here. So 4 divided by 20 again would be 0.20. 4 divided by 20, 0.20. 1 divided by 20 would be that 0.05. And lastly, 2 divided by 20 would be the 0.10. Okay. Now for the cumulative frequency, again, remember we're going to start at the bottom since that's our lowest number of 13. And we're just going to add those frequencies together as we go up to the top. We know we'll have the right answer because our top frequency should be, oh my goodness, my brain went dead for a second, should be 20. So we're going to start with 13. 13 had 2, so now we're going to add 2 plus 1. That's going to give us 3. 3 plus 4 will give us 7. 7 plus 4 is 11. 11 plus 4 is 15. 15 plus 2 is 17. 17 plus 2 is 19. And then 19 plus 1 is 20. Again, when you do that cumulative frequency, we always have to start with our smallest number, in this case at the bottom, and move our way up. So sometimes you might see a frequency distribution where your smallest number is at the top, so then you would start at the top and move down, but you always have to start with your smallest number, in this case at the bottom. So when we do our cumulative percentage, there's a couple different ways to do this. If you're not comfortable with adding up the percentages, so you could just take the percentages and multiply them by 100 and then add up as you go. Or if you don't like that, you can do the cumulative frequency divided by n times 100%. That will give you the same number here. So for instance, if we were doing that very first one, let me slide this over here real quick so we can see. So we would do our cumulative frequency 2 divided by 20 times 100. And that would give us, oops, I messed up, guys. So 2 divided by 20 times 100. There we go. So that's going to give us 10% here. So 10%. And then we do the same thing. 3 divided by 20 times 100. That's going to give us 15%. And then 7 divided by 20 times 100. It's going to give us 35%. 11 divided by 20 times 100 is going to give us 55. And 15 divided by 20 times 100 is going to give us 75%. 17 divided by 20 times 100 is going to give us 85%. 19 divided by 20 times 100 is going to give us 95%. And then just like on our cumulative frequency, our cumulative percentage, the last one should always be 100%. And 20 divided by 20 is 1 times 100 would give us 100%. Okay. There. So that would be our completed chart. Again, the biggest thing are those last 3 columns that we had the most trouble with. So remember, when we're doing our percentile, it's just F divided by the frequency divided by the number of data points. And the cumulative frequency, the easiest way I can tell you is to do the cumulative percentage, give the cumulative frequency divided by n, and then multiply that times 100%, because we are actually wanting this as a percent, whereas in the percentile, we were just asking for the decimal representation. Okay, so let's do the next problem. It said a set of score ranges from the high of 63 to a low of 28. If these scores are grouped in a frequency table, what would be the best choice for class width? So remember, when you're doing the class width, what you want to do is you want to find the range first. Remember, that's just the high minus the low. And then what you're going to do is you're going to divide by the most common widths, class widths that we have, which are going to be 2, 5, 10, 15, and we can go on for that. And what we're looking for is when we divide, the one that is closest to 10. Okay, so let's start off in finding our range here. So we're going to do 63 minus, 28. So 63 minus 28 is going to give us 35. So then we're going to take 35 and we're going to divide it by 2. So 35 divided by 2 is going to give us 17.5, which we're always going to round up to 18, and that is way too big. Remember, we want this number to be as close to 10 as possible. So then we're going to do 35 divided by 5. So 35 divided by 5 would give us 7. That's looking like what we want. That's close to 10. If I did the next number up, which would be 35 divided by 10, I would get 3.5. That's way too small. Okay, so too big, too small. It's like our Goldilocks right here. So our answer here would be a class width of 5 points. Remember, we want to try to make our class width kind of those nice pretty numbers, 2, 5, 10, 15, 20, things like that. We don't want to do kind of weird numbers like 7, okay? We want to have nice class widths on those. Okay, which type of frequency graph should be used with nominal scale data? So remember that nominal scale data is just categories. So that's like your hair color, your eye color, things like that that are categorical, and you cannot rank them. They're just categories. So when you're talking about categorical data, the only option you have is a bar graph. Okay, a lot of people on this question said a bar graph or a histogram. Now remember, histograms are quantitative data, That's number data. You can only use histograms when you have physical numbers. You cannot use them for nominal data. So the only thing we actually can graph as far as nominal data is bar graphs. All right, so this one says the students in a psychology class seem to think the midterm exam was very difficult. If they are correct, what is the most likely shape for the distribution of the exam? So here's the different shapes we can have. We've got a positively skewed. Remember, the data is all on the left-hand side. So data to the left. We've got our symmetric graph here in the center, which means everything's right there, lines up, mean, median, mode in the center. And then we have our negative skewed where our data sits to the right. Now, when you're looking at this number line here, because this is a number line, remember that these are your smaller values over here on the left. These are your larger values on the right, and that's true for every single one of these. So if you think the midterm was very difficult, that means that you expect that the vast majority of people are going to score low. Okay, right? The harder the test is, the lower the average. Well, that means that if I think the vast majority of people are going to be scoring on the smaller side or the lower side, that would be positively skewed, because I'm thinking that my vast majority, the mode of the scores, is going to be over here to the negative or to the left side of my graph. And I might have a few positives over here, but the vast majority are going to be this, which would be a positively skewed graph. Okay. Which of the following is not an appropriate interval to use when constructing a group frequency distribution? We just talked about this. 2, 5, and 10 are fine. We do not want to use arbitrary numbers like 4, so the answer in this one would have been 4. Remember, 2, 5, 10, 15, 20, those are the kind of class widths we want to try to keep in our group frequency distributions. All right, for the data, find the sum of the x's. Now, remember, when you're trying to do this, you can't just add up this x column, because remember, we have to take into account the frequency. So what you want to do is you want to come over here and you want to multiply the x times the frequency all the way down the entire thing. So 4 times 1 would give us 4. 3 times 0 is 0. 2 times 2 is 4. 1 times 1 is 1. Then you can add up this column and you would get 9. And the sum of the x's is equal to 9. So remember, it's not enough just to add up the x values. You have to multiply the x times the frequency. This is the x times the frequency. Then you can add that up, because that's the actual number of times those data points appeared. Which type of frequency distribution graph should be used for data that is on an interval scale of measurement? So interval, remember, this is quantitative. This is our numbers. So these are number values. So we can use a histogram. Again, remember we talked about that earlier. Histograms are used specifically for quantitative data, or we can use a polygon. Polygons and histograms are basically the same graph. It's just histograms are using the bars that touch. Remember our histogram bars that touch? And polygon is just a line. But other than that, they're pretty much the same thing. You're having your frequencies here on your vertical axes, and then on your horizontal axis, you either have your classes for your histogram, or you have your midpoints for your polygon. Okay, so, but either one of those would be appropriate for a interval scale of data. Bar graphs are not appropriate for interval scales. Bar graphs should only be used for nominal or categorical data. So a researcher collects a sample of 20 introductory algebra or introductory psychology textbooks and records the number of pages in each book. The results are then placed in a group frequency distribution using the intervals 0 through 99, 100 through 199, 200 to 299, and so on. If the results were converted into a frequency distribution, what kind of graph would be appropriate? So the second you see a grouped frequency distribution table, that should tell you that this is going to be a histogram. We're dealing with quantitative data because we are talking about the number of pages. Number of pages is numbers, so definitely histogram. And again, if I can do a histogram, I can immediately also do a polygon. Again, the only difference between the polygon and the histogram is whether or not you're doing lines or bars. Okay, the statistical techniques are classified into two major categories, descriptive and inferential. Describe the general purpose of each. So remember, when we're talking about descriptive, it's really kind of in the name. It describes the population or sample, either one, using graphs or tables, or we do our measures of central tendency. That's our mean, median, mode, standard deviation, variance. All of those kind of things are all descriptive statistics because you're just explaining what the data looks like. Whether it's a population, whether it's a sample, doesn't really matter. It's just that descriptive. So inferential statistics, the biggest thing here is you're using a sample from a population to make generalizations or predictions about the population. The key thing here is you're doing generalizations or predictions, and that you are taking them from a sample. So basically, we're taking a sample of people, we're doing some type of experiment with them. Maybe we're looking at anxiety levels, or we're looking at a certain type of therapy to see if it works appropriately. And then we're trying to make a generalization from our sample back to our population and saying, hey, this worked for our sample, so we think it will work for our population. This didn't work for our sample, so we don't think it's going to work for our population. The big things on inferential statistics is how we get those samples and how closely they are related to our population. The closer we get our sample to our population, as far as the descriptive statistics, the means, the medians, the modes, all of those things, the better we can predict whether or not whatever experiment or technique we're using with our sample will also work for our population. If you have any questions about any of these that I went over, or if there's a question that you saw on the exam that you don't understand, please email me and I will be more than willing to talk to you about why the answer is the way it is. You guys have a great day.